Welcome to The Explainer. Today, we are tackling one of history's greatest what-ifs. We're going to apply a modern civil engineering lens to an ancient wonder. We've built skyscrapers that touch the clouds, we've even been to the moon. But could we actually, really, rebuild the Great Pyramid of Giza? Okay, let's just jump right into it. On the surface, it seems like a pretty simple question, right? I mean, with all of our technology, all our massive machinery, surely this is a challenge we could knock out of the park. But when you really start to break it down, piece by piece, the answer gets a whole lot more complicated. And believe it or not, the reason isn't because we lack the technical skill. We absolutely have the capability. The real roadblocks, the things that make this basically impossible, are purpose, an almost unimaginable cost, and a scale that just completely shatters modern project management. You see, the ancients had this incredibly powerful religious drive. We have budgets, stakeholder meetings, and feasibility studies. So, to really get why this is such a monster of a challenge, we have to translate its ancient size into modern engineering terms. And I'm telling you, the numbers are just staggering. It's hard to even wrap your head around them. Just try to picture this. We're not talking about a tall, mostly empty building. We're talking about a solid mountain of stone, 6 million tons. That's made up of 2.3 million individual blocks, and a lot of these are the size of a large SUV. It is an almost incomprehensible amount of stuff to have to move and place with precision. Every single megaproject, I don't care what it is, starts from the ground up. But for a structure this heavy, the ground itself becomes your first, multi-million-dollar problem. You can't just plop down 6 million tons of rock anywhere you feel like it. And this chart just illustrates the problem perfectly. The Great Pyramid exerts 12 times the ground pressure of the Burj Khalifa, the tallest building on the entire planet. Even with its own gigantic foundation, the Burj Khalifa is practically a featherweight compared to this. This isn't just a modern concern. The ancient builders, they learned this lesson the hard way. The bent pyramid, it actually had to be modified halfway through construction because its foundation was failing on unstable ground. It literally started to lean. So from a modern engineering perspective, just finding some flat bedrock isn't going to cut it. Not if you want it to last another 4,500 years. We'd have to build a massive reinforced concrete mat. The foundation itself would be its own mega project, using as much concrete as many modern skyscrapers. And just to get to this point, just to buy the land, get the permits, do the scans, level the site, and pour that monster foundation, we've already spent over $500 million. And that's all just for the foundation. We haven't even touched a single block of stone yet. So now we move to the next phase, getting the materials. And this is where the logistics go from just, astronomical to truly mind-bending. Okay, so our foundation is ready. It's a perfect laser-leveled $500 million slab of concrete. Now all we got to do is source, cut, and ship 2.3 million stone blocks to put on top of it. Sounds simple, right? Wrong. Get this, if a single modern quarry worked on this project, just one, supplying about 100 blocks a day, it would take them 63 years. So to meet a more, let's say, reasonable 5-year project timeline, you would need 250 of these industrial diamond wire saws, all running at the same time. Now look at these costs. The raw stone alone is estimated at $1 billion. To put that into perspective, the entire construction budget for the Burj Khalifa was about $1.5 billion. We're spending 2/3 of that just on rocks. And that's before a single one of them has been moved an inch. This would be one of the biggest, most sustained transport operations in history, just for one project. For 5 years straight, a fleet of 500 trucks would be on the road constantly, creating this 900-kilometer-long conveyor belt of stone. A new truck would arrive at the construction site every 10 minutes, 24/7. So after we factor in the foundation and all the logistics of getting our materials to the site, our running total has just rocketed past the $2 billion mark. And we still have to actually, build the thing. The blocks are arriving like clockwork, every 10 minutes. But now we get to the most dangerous, the most technically complex, and honestly, the most physics-defying phase of the whole project, the assembly. Right, that's the million-dollar question. Or, in this case, the billion-dollar question. Those granite beams that form the roof of the King's Chamber weigh up to 80 tons each. And the simple answer is you can't lift that with a single crane. The laws of physics just get in the way. The longer a crane's arm, the less it can lift. It's as simple as that. So what we'd need is a whole network of the biggest, most specialized tower cranes on Earth. And as the pyramid gets higher and higher, these cranes would literally have to be taken apart and then reassembled on the structure itself, layer by layer. It's an incredibly slow, ridiculously expensive, and extremely dangerous process. And on top of just stacking the blocks, you've got the finishing touches. You see, the original pyramids weren't the sandy brown color we see today. They were covered in 115,000 blocks of polished white Tura limestone. They would have gleamed so brightly in the sun you could see them for miles. Recreating that finish, that adds another $250 million to the bill. So, after 8 years of this theoretical mega project, with a budget that makes your eyes water and an army of engineers and workers, what have we actually built? And more importantly, what does it all mean? This is our final and I'd say pretty conservative estimate, nearly $3 billion. And that doesn't even include taxes or the cost of building a dedicated power plant just to run the quarry operation. For that kind of money, you could build the world's most expensive stadium or a massive natural gas plant. And this, right here, is the ultimate takeaway. We would spend $3 billion on a structure with basically no modern function. It's a tomb for one person. It was built to last for eternity. And well, it has. It's been standing for over 4,500 years. Our modern megaprojects, they're built for millions of people, but they're often designed with a functional lifespan of 100 years, if we're lucky. This quote from the archaeologist Zahi Hawass just perfectly nails it. The real value of the original project wasn't just the pyramid at the end. It was the act of building it. It was this massive national project that organized labor, it advanced engineering, and it mobilized an entire civilization for a single unifying purpose. So in the end, this whole engineering exercise isn't really just about cost and logistics. It leaves us with a pretty profound appreciation for what the ancients achieved, and it asks a really challenging question about our own modern legacy. What monument to our civilization will still be standing in the year 6500? Something to think about.